welcome everybody. Thanks for dialing in. Just to set the scene, so I'm not a disembodied voice coming out of your laptop. I'm here in Denver, Colorado, and I have some additional attendees in the room here with me. And so actually in the conference room wall here, there's a note written and it says, if you are in this room during the live webinar, please do not talk, sneeze, laugh, breathe loudly, or stomp your feet. So I can only assume the prediction of laughter is an expectation of wit rather than me screwing up. So we're here to talk about the path to Industry 4.0. And what we're going to do is kick off and talk about what is Industry 4.0. It's important that we get a definition around that. There's a lot of talk, a lot of hype around Industry 4.0 now. Some of you may be familiar. But let's start with defining what it is. And then actually, we're going to talk about a few of the results from a survey that we just did. We had over 250 respondents from various manufacturing industries, asking them about the status of their products and processes. And what was revealed to us through that is that many people are not really ready to adopt Industry 4.0 today. In fact, our next agenda item here is to talk a little bit about adopting Industry 3.0 and some of the value you can get from that. And then and only then will people be ready to move up into this brave new world of Industry 4.0. So a little bit about me. I see the marketing people found a picture of me preparing for the webinar last night. So yes, I am indeed a recovering rocket scientist. I used to do nefarious things with missiles back in the UK, and I ended up getting posted over here to Rocket City, USA in Huntsville, Alabama to continue doing nefarious things with American missiles. So from there I moved out into, about 15 years ago now, into this field of location technology. And location technology in the context of bringing location awareness and location-driven visibility and controls. And most recently here at Ubersense, that has been in the field of manufacturing. And my title here is CTO for the Americas. What that really means is dot connector, connecting our product strategy with market needs, connecting our solutions to customer needs. And it affords me the advantage of getting to spend time with a lot of different manufacturers in a lot of different industries in a role where my job is really to understand what their problems are and what their goals are. So it gives me a good cross-section of the issues that are facing people today. Yes, I am indeed a dog lover. Thanks, guys, for putting that on there. Cat lovers are also perfectly welcome on the webinar. So, Industry 4.0, what's that about? Well, there's a lot of hype out there right now, a lot of talk about Industry 4.0. And if you go out on the web, you can do a Google search, a Google image search on Industry 4.0, and you'll find many, many versions of this, which puts Industry 4.0 in the context of 4 industrial revolutions. The first of which in my high school in England I was taught was the Industrial Revolution. Back in the 18th century was the introduction of mechanized production, the use of steam and water power to take machines to do some processes that were previously manual. And then here about 100 years later, the second Industrial Revolution, introducing the era of mass production, obviously most famously epitomized by Henry Ford and a Model T Ford, where the goal there was to, through division of labor, through assembly lines, to churn out many, many copies of the exact same product and thereby significantly reduce the cost, make them available to many more people. Fast forward again to the late 60s, early 70s, when microprocessors became small enough and cheap enough and robust enough to deploy, and we entered the third industrial revolution of the introduction of computerized controls into manufacturing processes. And then here what you'll see in the fourth industrial revolution, when you go out there and search the web, you'll see a little arrow that says today, and it'll talk about this fourth industrial revolution. And the industrial revolution here is this world of cyber physical systems. What does that mean? It means sensors throughout the operation, all the way from start to finish. And that might mean through parts distribution, manufacturing assembly, distribution, dealer networks, right out through the life cycle of products of the customer itself. a huge body of real-time knowledge through distributed sensors connected together in a central big data analytics engine which continually strives to optimize the entire organization in real time. An exciting future. But you'll see that according to a lot of the conversation out there, this is happening today. So a quick poll question, just to get you guys warmed up a little bit here. From what we've talked about so far, from what you know about Industry 4.0, how close do you think your organization is to adopting Industry 4.0? Just click on the one that most suits. I'll give you just a few seconds to do that. Okay, so let's have a look at the results there. And about a third of you doing it now. The rest got plans to start. I guess 20% haven't really thought about it yet. That's pretty consistent. Industry 4.0, and we're going to come back to this here, is not necessarily today for all people. And I want to really get away from the notion of the dates on this thing in its entirety, because it's not true to say that everybody after Industry 2.0 started mass producing all products on assembly lines. Even today, there are many kinds of products that are not produced that way. It's also not true that everybody has adopted computer controls on a large scale. And even in an individual plant, you find areas of computerization, areas of robotics, areas of manual work, and so on and so forth. So the fourth industrial revolution, that can be some way off for a lot of us. And the question when you look at the press out there and listen to the hype is, gosh, are we getting left behind? Should we be getting on this right away? And the truth is no, and that's what we're going to talk about here. So I'm going to ask you one more quick question here. Either you or your colleagues or someone else in your area of work, do you think you spend at least an hour a day searching for assets or products at some point in your processes? And assets might be tooling, they might be jigs, calibration rigs, products might be in process, they might be in buffer areas, waiting processing. How many of you spend at least an hour a day searching? Okay, let's have a look at that. And 79% of you said, yes, you do. It's interesting, actually, because when we did a wider poll, yeah, 73% came back with the same answer, that, yeah, they spent at least an hour a day searching for things. And 20% said up to a couple of hours. And look at the blue one. 3% of people said they spend more than half their day simply searching for things. And the point to bring this up to you is that this is a far cry from Industry 4.0, right? Industry 4.0 being this data-connected world of real-time visibility throughout the entire operation at all times is almost the antithesis of, you know, 93% of people have a hard time just finding where stuff is. That's pretty typical. You find this in many places, and it's all about visibility. And visibility is so crucial in manufacturing. Manufacturing really is a process of motion. It's the process of getting the right parts to the right workstation with the right person and the right tool at the right time. It's a dance, a carefully choreographed one. And visibility is so important in terms of being able to monitor that flow. And that's exactly what we asked again in another question, which was, how much visibility do you have into the real-time status of your manufacturing process? Not where my stuff is in the plant, but now, where is my product in the process? And a good chunk of people had, almost a third there on the right, had good real-time status. But on the left there, you see a significant chunk of people with either the simple visibility of an and on board or no visibility at all. And again, this is a different kind of visibility now, but equally critical is where through the process are my products? Somebody once very importantly said, you can't improve what you can't measure, and you really can't measure what you can't see. So if you can't monitor stuff through your processes, then continuous improvement becomes a challenge. So I'm not alone in thinking that Industry 4.0 might be some way off for a lot of people. Gartner, you may have seen this, Gartner publish on an annual basis what's called the hype cycle. It's a very useful tool. Don't read all the details here, there's lots on here, but just the general shape of the curve talks about the expectations people have of new technologies. Over on the left, when they're introduced, not many people know about them back then, expectations are low, but then the hype starts to build to this peak of inflated expectations. And what happens right after that is this trough of disillusionment, when the reality of, gosh, of what this means really starts to sink in. And then these technologies become viable and adopted, and they reach up to this plateau of productivity. Now, I'll give you a personal example here, NFC, near-field communications. I've been excited about that for a long time. I was there back at the start, creating standards for the technology, and it's gone through this peak of inflated expectations, and finally today I have a new phone with an NFC chip. I have a Google Wallet. I'm so excited about paying for things by my phone, and I find absolutely no infrastructure out there for me to use it. The only thing I've been able to buy with my phone so far is 3 bottles of overpriced water at the airport in Huntsville, and that's very disappointing. Now, the Internet of Things, if you look right at the top, the peak of inflated expectations, Internet of Things is kind of a big term encompassing Industry 4.0. It's the term that encompasses the idea of distributed sensors monitoring in real time and reacting and optimizing. And that's where we are with Industry 4.0. Lots of talk, lots of hype, lots of excitement, but the reality is going to set in. Industry 4.0 is going to be a very challenging thing for companies to adopt. And we'll talk a little bit more about that just as we go through here. So we talked about visibility. Do people have visibility to data? Varying degrees of answers there. And then we asked them, okay, if you do have visibility data, what are you using it for? And 73.4% there on the left said monitoring progress against plan, pretty common. How many have we produced versus how many do we expect to produce at this point in the day, for example. Fewer people looking for improvement areas, fewer still identifying problems as they occur, and only 40% trying to identify problems before they occur. And the question then becomes, if you have visibility data, why wouldn't you be doing all these things? Why weren't all these answers 100%? If you have visibility, why wouldn't you be looking to identify problems before they occur? Well, the truth, obviously, is that not all visibility data is created equal. And so we ask people, where do you get that data from? Where's your visibility coming from? The number one answer is my team, their observations. Good, important data, but very objective. 59% of people said their personal observations. And the reality there is two things. One is it's hard for one person to see an entire process all at the same time. The processes could be distributed across multiple parts of a building, multiple parts of a site, multiple different sites, in fact. One person can't see that at once. It's also hard to break out time just to do that and stand and observe and learn. So people engage in independent analyses, and 31% people said they do that, but don't you just know it? Anytime you watch a process and monitor how it's going, it runs just perfectly. And only 16% have sensors that measure process flow, and I would hazard that back at the start when we asked people whether they were engaging at Industry 4.0, that the group of people who said, yeah, we're getting started now, are that group of people who are already well ahead in terms of having real objective sensor data to monitor flow. And that's an important step towards Industry 4.0 for certain. So if you don't have good data and you can't monitor processes, what happens? Well, quality issues can occur, mistakes can occur, and we asked people about the biggest cause of quality issues. And what we found was that where there was a preponderance of manual processes, half of the respondents said one of the biggest quality issues was caused by workers not adhering to the design process. Another third said inexperience of new line workers. So that's 84% who, it seems like, are just blaming their people. Now the question here is that really true? Do we have a crisis in manufacturing where our workforce is so poor that they're making all those mistakes? And of course, I don't believe that for a minute. I suspect many of you don't either. Certainly new workers take a little bit of time to ramp up and become maximally productive. But what's the root cause here? Let's just take a little pause here and talk about, go back to here, because I think there's something missing. I think it's exciting to talk about Industry 4.0, but I think there's an interim milestone here between 3.0 and 4.0. I'm calling it 3.5 here. The introduction of mass customization, or let's say the reintroduction of mass customization, in fact. Before Henry Ford started churning out Model Ts, if you brought an 18th century gentleman forward, and he'd be astonished to find that we go to the store and buy clothes that are about the right size for us, give or take, depending on what's on the rack. Of course, before the introduction of mass production, all products were bespoke. Mass production introduced the concept of a mass market and treating your customers as a homogeneous base who are willing to compromise what they really want for price. But, you know, fast forward to the late 90s, and companies like Dell really changed that, turned it on the head. You could get online, you could spec exactly the computer that you wanted, and it would be built to order and shipped right to your door, giving you a highly personal experience, giving you personal choice. And that concept of mass customization now is becoming much more pervasive through many industries where consumers are really wanting choice. And when you couple mass customization with mass production, then you have a difficult problem on your hands. So on the path to Industry 4.0, we really have to stop and consider another important milestone in terms of complexity. So back to the workforce. Is our workforce so unskilled that they can't manage these complex processes? Well, let's make a distinction between complexity and variability. The manufacturing workforce today is actually highly skilled. They can manage very complex processes very efficiently and very accurately. And human beings are excellent at repeating the same process over and over. It's called muscle memory. What humans aren't brilliant at is variability. Variability meaning the process is slightly different every time. In a world of mass customization where every product might be slightly different, every process might be slightly different, and you get into this issue of, let's call it switching time, right? I've got to switch my brain over from one process to another. And I would contend that variability is the process killer, not complexity. So quickly here, I want to poll you again. Make sure you guys are all still with me. In terms of the product that your company is building, how many different variations of that product do you build on a single line? When you look at all the types and options and variations there, how many different variations would you build on a single line? I'll just give you guys a second to click away there. Okay. Again, about what I expected there. Interestingly, 0% said one. If I'd asked Henry Ford that question, he would have answered one, right? They're all, you can have any color you want as long as they're all black. Tens, hundreds, and even thousands, split pretty evenly there. Even managing tens of variations is difficult. Managing thousands is quite a challenge, especially in mass numbers, and that's quite typical. The automotive market is the poster child, I guess, of very high volume production with many thousands of different variations. So variability, that's the process killer. So when we ask people, how do you see, what's the biggest opportunity to decrease the cost of quality, improve quality, 55% said better worker training. 35% said fault-tolerant process design. A quick poll for you again. Let's just bring up another one real quick. In terms of, for those of you, this won't be all of you, I understand, but for those of you with a number of manual errors in your plant, manual processes where errors happen, how many of you think that the issue is the people, and how many the process? Just give you a couple of seconds there. Okay, let's take a look at the results there. So split about similar, about 60-40. And once again, certainly there's an area of improvement in terms of better training for people. But a good chunk of you also point to the process as an issue in itself. And that's really what I wanted to come back to, is that when you introduce a high degree of variability into your manufacturing, we are starting to ask a lot from our workers. And we do have to take a pause here and look at our process design and our process controls and see if we are helping them to do their job. Here you go. Here's another one. Variability requires flexibility in order to build, and one of the ways people are enabling flexibility in plants is moving over to wireless tooling. And the great thing about wireless tools is you can use them anywhere, and the terrible thing about wireless tools is you can use them anywhere. And the problem is, once you've given this freedom, you've kind of increased the scope for errors happening. What if I go make an operation with my wireless tool on the wrong product, and now my quality record's all messed up because it's recorded against the wrong product ID? So we asked people what percentage of wireless tools they had currently in the plant today, in orange there, and not that many, right? That's very typical. There's still a lot of tethered, corded tools out there. And we asked about an estimate in 5 years' time, and you see over the next 5 years an expectation of a fairly large uptake of wireless tooling. I wanted to ask you guys the same question, just real quick here. In terms of today, in terms of the tooling that you use, hand tooling I guess we're talking about here, what percentage of your tools are wireless today? Just give you a couple of seconds there. Okay, let's take a look at those results. Pretty good split there. You guys are using more wireless tools than maybe some of the people in the survey. But again, the point about the survey here, the point about asking you the question is there's a pretty big momentum building behind wireless tooling, which really for me is a reflection of trying to introduce some flexibility into processes. But once again, how are you going to manage that flexibility? So talking about this path to Industry 4.0 then, the whole point of the webinar here, I want to come back and just talk about really adopting Industry 3.0 in a little bit more thoroughly, and especially in the three areas here of gaining visibility so that you can measure process flow, getting better control of processes, but also introducing what I like to call reactive controls, context-sensitive controls, if you like, that can cope with variability. And this is the path to Industry 4.0. Adopting these technologies is the thing that's going to get you ready when 4.0 comes. So I'm going to talk through some concrete things that you can do now in 4 different areas in terms of asset visibility, process visibility, error proofing, and reactive controls. And I want to go through each of these, and then we're going to step back to the wider context of how is that getting me towards Industry 4.0. So let's start with asset visibility, and this really is one of the most straightforward things you can do for a couple of reasons. One is that the cost of not having this visibility can be quite clear, actually. If people are spending time searching for products or tools, whatever it is, that's just a lot of non-value-added search time, right? So that's burning payroll, and that's making people inefficient, and that's an easily calculated cost. It's also slowing down your cycle time. If products are sitting being searched for and not being worked on, then they're spending more time in the entire process than they should do. That's decreasing your throughput. It's hitting inventory levels. It's increasing your inventory costs. So once again, it's quite there are some quite clear, hard returns on how asset visibility can cost the company operational cash. It's also somewhat straightforward to solve. The problem here is to be able to figure out where everything is. Obviously, you're going to be introducing some sensors here. This is all, as I said, the road to Industry 4.0 and connectivity with sensors. And here you're looking for some kind of tracking technology that's going to locate things. So you've got to ask yourself questions. And step 1 is what's the cost of this problem for us? Step 2 is what do we need to achieve? Well, do I need to know roughly where things are, just in this area of the plant, in this building versus outside? That level of granularity maybe points you towards an RFID solution that simply tells you in a large area where things are located. Do you actually need to know a little bit more granular than that? Maybe which particular corner of the plant this is in, or which part of the yard. Now you're going to be looking for something more like a tracking solution. You'll commonly see those referred to as real-time location systems, RTLS. Outside, maybe that GPS, maybe GPS, for example. So have a think about what do you need to achieve, what kind of granularity of data that you need. But now when it comes to deployment of these systems, something really important is that you are going to be building out sensing infrastructure. They may be RFID readers, they may be location trackers, but there's going to be infrastructure. It's going to require networking. It's going to require a server to run the analytics. And so this is a project that really has to be done in partnership with your IT department. IT is going to be a critical partner in finding, deploying, and supporting these kinds of technologies. And the reality of asset visibility is it's often going to be in parts of the plant that don't already have good infrastructure coverage from an IT standpoint. You may not have Ethernet and switches out here. You may not have Wi-Fi coverage. And those are the kinds of networking technologies you need to connect to these sensor systems together. So asset visibility, look to your costs, look to what you need to achieve, and deploy these in close partnership with IT. When you move up a level and we start talking about process visibility, process visibility is the task of answering not the question, where's my stuff in the plant, but where's my product in the process? And this is going to step up a level the sensing technologies and the sensing connectivity that you need. So there are lots of ways that process status can be measured. For example, we might be looking for feedback from tool controllers that are indicating a job done correctly. We may be looking for feedback from any robotic elements you have in a production process saying that the process is complete. We may also be trying to monitor the movement of products physically through the plant, because in most cases a particular process happens at a particular place. So motion is a very important indicator of the status of the process. But now that location information has to be quite granular. You need to know one workstation from the next, so now you'll be looking at much more precision in your location system. But once again, there's a multitude of sensors here, and it's also critically important in these kinds of deployments to look to IT as a critical partner in deployment and support. But there's another thing to talk about here as well. You can't solve problems just by gaining visibility. It's no use seeing the mountain in front of the plane if you don't subsequently pull back on the stick. And so as you go into a process visibility project, it's important that everybody understands that the purpose of this is to make change, to measure flow, to identify bottlenecks, to fix problems, and change processes. So it's important to think of process visibility as a piece of a change management project, and the technology, the sensors that help you do this, as the thing that supports that change. So it's really important. I can't emphasize that enough. I've seen people really struggle to create change when it comes as a surprise to them after installing visibility systems that indicate they have issues in the process. Change is the whole point. Visibility is the tool. When we move up a level again and we start to use this data, process data, visibility data for controls, we get into the world of error proofing. And this is back to where our conversation about complexity of task versus variability of task. And what we're trying to do here is help people with variable tasks and prevent them from doing the wrong thing. So here's a typical example, the picture of a guy with a cordless tool, and we want to make sure that tool runs in a particular place on a particular process, but we need to disable that tool if it's the wrong product, the wrong process, etc. So we give them the freedom, and we also give them the automatic backup to say, oh, no, that's wrong, and prevent the mistakes happening in the first place. So again, this is sensing. We need to know where the tools are, for example, in this example, the status of the vehicle. We need to be integrated to other systems to understand the options on this particular product. But this can be done at a very local level. You can do this on a single process. There might not be actually any IT integration particularly at all. It may simply be a small local error-proofing system hooked directly into a PLC controlling a tool. So with error-proofing, you can start very small. As this rolls out, though, onto more of the assembly line, it will become, again, an IT partnership, because as you start to roll out these sensor networks over larger and larger areas, there's a very big infrastructure component to these projects. So error-proofing is really the process improvement piece that we were just talking about previously as to how do you help people do their jobs better. And even up to the point here where we start to introduce what I referred to previously as reactive controls. And by reactive controls, what I mean there is these error-proofing controls that really understand the current situation and can react accordingly. So I'm going to give you an example here, and an assembly line, an automotive assembly line is a good example, because quite typically what will happen is you'll have a very short takt time here, right? Everybody has maybe let's say 60 seconds to complete their sequence of tasks. And if that task is not completed by your physically constrained workstation, this line on the ground, often actually a line painted on the ground, if you're not done by then, one of two things happens. An error propagates forward, job just wasn't completed and has to be completed down the line or off the line, or the line stops until the guy has time to complete the task. And both of those are very costly. What if I was tightening a bolt, and but for the want of a couple of extra seconds, I would have finished? But the rigid system is set up where if I'm not done by the line stops. Now I have to complete the task, call a supervisor, have the bypass keyed out, and get the line started back up again. I just wasted 20, 30 seconds when all I needed was 2. So why can't these controls react? If the controls understand the guy's almost finished, I just need to give him a bit more space. I need to temporarily open up his workspace to let him finish, give him the chance to catch up and work ahead. Then I can eliminate a lot of errors forward, a lot of line stoppage, and those accumulate to big costs in terms of loss of throughput on a line. So again, this is very similar in terms of deployment to an error-proofing system. You can do this locally. You can do this on a single process, independently and alone. As you try to do this along big sections of the line, it will become an IT project as well. But there's another important piece, and this harks back to what I was talking about in terms of process visibility. You are trying to implement change here. Reactive controls are simply a tool to enable your bigger goal of making a fundamental shift in the way you build products, in breaking the fixed workstation paradigm and allowing that workstation some flexibility, some variability that enables the workers to cope with the highly complex, highly variable processes we're throwing at them without being so physically constrained as they are now. So again, this has to be done in consultation with all your constituents, understanding that you're engaged in a change effort and really engaging the workforce in these kinds of things. You will be changing the way they do things. There will be training. There will be some ramp-up time for them to get used to it. And these guys have important and really valuable feedback on how these reactive controls work and either help or don't help them to do their jobs. So what we just talked through there is all Industry 3.0 stuff, but it's all important steps on the path to 4.0. It's all a matter of introducing sensing technologies, of networking sensing technologies, of leveraging those sensing technologies for long-term monitoring of processes to identify bottlenecks, of real-time controls, of context-sensitive controls. And they're all paving the way for 4.0, but it's all 3.0 thinking. So let's talk about 5 steps to 4.0. How do you get there from here? So the first thing, and this is the 4 topics we just previously talked about, visibility, asset visibility, process visibility, controls, and reactive controls. Those can all be introduced in a rather selfish way. And that really is my advice to you to get started on this road, is to be selfish. And what I mean by that is start small and start local. Pick a problem, pick a pain point, tackle that, and prove to the organization and yourselves that these things really work. I mean, these solutions are out there. They're providing value to people, but you need a proof point, and the best way to do that is to start small. I can't tell you the number of times I've seen people struggle when they get excited about all the things that visibility and controls can do for their process and trying to do everything at once. You quickly get tangled up in something that's just too big to bite off in one go. So start small. The next step is be forward-thinking. You know, quickly what happens when you've instrumented a single process, say you've introduced error proofing on one process in the line. As you start to see the benefit, you're going to start to want to roll that out sideways. And by sideways, I mean to similar other processes. Well, it's at this point that it's really good to just take a pause, have a quick look at what's my ultimate goal. There are lots of different sensor options out there, lots of infrastructure options. They have their strengths, they have their weaknesses, and the critical thing here is to invest in the right infrastructure at the outset. Think about your next step, but think about your ultimate goal, because introducing these kinds of technologies has a large infrastructure component to it. There is going to be an effort in terms of the physical installation of sensors, the physical wiring of sensors, the creation of server space to run the applications. You don't want to get 2 steps down your 5-step path and find out that you've reached the limit of the infrastructure you deployed. It's extremely costly to go back and either replace infrastructure, worse still, to add an overlay sensing technology to take you the next few steps, which now leaves you managing 2 separate infrastructures. So do be forward-thinking when you start to think about taking bigger steps. So the next thing is be cooperative. Again, here's what happens. A certain department, let's say on an assembly line, this is getting deployed there, and we're starting to see value. Now, quickly adjacent functions start to see the value of that and think, well, this could be useful for us. A typical example just recently that I saw was a company who had put some visibility and control solutions on the assembly line, and now the materials handling department is saying, look, we could really benefit from that with delivering parts line side. We'd like to track our parts tugs and monitor their flow through the factory. We'd like to optimize their routes. We'd like to understand if they're getting behind schedule and risking a parts shortage on the line. We'd like to adopt this. And this is the point where you need to be cooperative and help these other departments. You're the expert now. Help these other departments expand what you've achieved kind of out into other departments in the organization. And there's a huge benefit for everybody when multiple parts of the organization invest in these solutions. So then the final step here, and we're still kind of in the 3.0 world of things here, is to be supportive. Again, I see this over and over. It's really quite typical that a single plant becomes the pioneer for these technologies, and rapidly that gains corporate attention. And quickly, what has become a bottom-up process in a single plant becomes a corporate mandate through every plant. And the blueprint that you've created now is adopted throughout the other plants. And at this point, you will be supporting your partners and your colleagues in these other plants in helping to kind of consult with them in terms of getting these systems up and running. So be supportive. And that brings us to this important juncture here, where we've got ourselves ready for Industry 4.0. And this is where I want to make what I think is the fundamental change that companies will have to make to adopt Industry 4.0. Everything we've talked about so far has been a bottom-up initiative. It's been the identification of point problems, the adoption of point solutions, the expanding of those solutions out to other similar problem areas, sideways into other departments, out through every plant. Industry 4.0 is a different thing. Industry 4.0 says, if we could see everything all the time, end to end, everywhere, and we could mash that together in this huge analytics engine that continually optimizes all parts of the process, that might take data from one area of your operations which will affect how it controls an entirely different area. That, to me, is a very top-down kind of activity. And when we come to adopting Industry 4.0, your role is to be collaborative. 4.0, because it is going to be a revolution which makes incremental improvements to every part of the organization and huge improvements to the organization as a whole, has to be this top-down initiative. They're from corporate, and they really are here to help. The goal here is to get a seat at the table and to be a part of that process, which is going to be a large, cross-functional, cross-departmental process. This is a skill that many companies will have to learn. A lot of times, the way companies are set up in certain functional silos, cross-departmental collaboration can be difficult and challenging. And when you do it on the grand scale of the entire organization, obviously the challenges multiply. So collaboration is key in terms of adopting Industry 4.0. And where that brings us to, on this path to 4.0, is what we've been doing all along here is adding layers of value. Through Industry 3.0, through the introduction of visibility and controls and reactive controls and understanding that hidden in 3.0 is this kind of 3.5 milestone of how do we marry mass production with mass customization, how do we help our people manage the variability. We've taken these steps through 4.0 of starting small and improving the process, of expanding on that to improve the department, of pushing that out sideways into other functions to improve the plant, of replicating that in other plants to improve this kind of manufacturing or assembly function. And then finally, the 4.0 step, this top-down step, which you're now ready to do, is the thing that improves the company as a whole. But all along this path, we've been deploying sensors, we've been networking sensors, we've been leveraging the data to make better and better choices from the ground up, and we're poised and ready then when Industry 4.0 comes at us from the top down to help introduce that and to benefit from the results. So the advice to you really is don't get lost in the hype. There is a lot of talk about Industry 4.0. All the graphics point to it happening today. But I will tell you, and look at the Gartner hype cycle, the key at the bottom there says that the expectation of 4.0 reaching the plateau of productivity, the kind of adoption phase, is 5 to 10 years. And there certainly are people that are out ahead of that. There are companies experimenting with 4.0 concepts on a smaller kind of scale. But you're not getting left behind because you're not adopting this massive conceptual change. There are many things that can be done along the road in terms of introducing visibility and control in the advanced stages of 3.0. And that's really the advice. The path to the 4.0 is to follow the steps that I laid out. Now, we've got some questions already in, and do feel free to add some more questions. That kind of gets to the end of what I wanted to talk to you about. and I hope it's been useful. It's a lot of stuff to try to cover and fit into a 60-minute webinar. So I'd be more than happy to follow up with some additional webinars on alternate topics. So while I give you a chance just to type in some additional questions if you have them, do take a moment. If there are areas, topic areas that you particularly like to hear some more about, I'd love to put together a more detailed, in-depth look at that, and we'll come back and do a webinar on that in the next couple of months. So while you guys are doing that, and I've got a few questions in. As I said, do submit some more questions if you need to. I do have a few here. Let me start to tackle those. So yeah, okay. So the first question, yeah, it's a good question. We've talked a lot about how do I get down the path to Industry 4.0, but the first question here is how do I actually start the conversation internally about Industry 3.0? Okay, well, yeah, good questions. I've kind of alluded to this a few times, and I want to really reinforce it again. The most important thing you can do to get started, there's three things. One, really identify what the root cause issue is. What is the specific pain point that you're trying to solve, and what's the result you need to achieve? Those are the first two things, and those are quite obvious, right? But the other thing is it's so critically important to right from the start to get all the stakeholders together. And as I've said to you before, very often these are things done in partnership with IT. It's critical to start working together right up front. There's really no use setting off independently down a path of introducing new technologies, introducing change, and later on bringing in important people who have a big stake in that. They will be surprised. You will put them on the defensive, and you will have created yourself a barrier in terms of moving forward. So I think the biggest thing I can say to answer the question how to get started internally is figure out what you want to do and get the stakeholders together right up front. So, okay. Yeah, I touched on this a little bit. A question from earlier, how many years off is Industry 4.0? Yeah, so, okay, so some people are doing a little bit of it now. I'm kind of with Gartner on the 5 to 10 years. I think that's probably a good time period for this really getting hold. But that's the start of it. If we're still in Industry 3.0, right? If we're still developing technologies and deploying technologies for this third industrial revolution that people point to as starting in about 1970, we're 40-odd years in and we're still not done. So sure enough, Industry 4.0 is coming, but the adoption of that is going to spread over decades. In 50 years' time, people will still be adopting Industry 4.0 concepts. So yeah, it's a good few years away for most people, and it could be a decade or more away for many of us. There's just lots of stuff we can do before we have to get there. So let's see. Got one more question here. And the question is, can error-proofing systems also be used for process visibility and asset visibility? Do you have to buy different systems to solve each issue? Okay. Yeah, that's a really good question. So back to my step 2 on the path to Industry 4.0 was be forward thinking. Now the answer to the question is there are certainly error-proofing systems which also provide visibility. There are certainly visibility systems that also provide error-proofing. But equally, there are many systems that only do one or the other. And this is really this question is the crux of why earlier on I talked about thinking ahead and really planning for what you want to achieve. You do not want to get stuck down a path of a single-use technology when you know you have multiple uses for it down the road. So and be careful navigating the landscape of all the solutions. I'm perfectly happy to chat with you about that if you wanted to do that. I've been doing this for a while, and I've understood really what the different technologies are, but you can get stuck down the wrong technology path. So do be careful about that. Okay, well, I think what we'll do is we'll wrap it up there. I wanted to make sure that you knew how to connect with me. We've got some good LinkedIn conversations going on about this topic right now. There's a white paper actually that I put together about the survey results. Obviously, the survey had a lot more stuff in it you might be interested to look at. So you can find me on LinkedIn, on Twitter. There's my email address. I'm happy to chat. Happy to chat anytime. So I hope this has been useful, and I do thank you for your attention, and I look forward to talking to you again soon.